Good morning, everyone, and welcome to day one of the CETA BIM gathering. This is Stream 2, Smarter Cities, Smart Buildings and Data. So I'm going to be chairing this morning on behalf of the UK BIM Alliance. The UK BIM Alliance are a group of industry individuals who have come together to promote BIM as businesses as usual in the industry. You can learn more about what we're doing, and there's a number of presentations. David Churcher is speaking about standards and guidance later on this morning, and Kemp is presenting this afternoon, and Casey Rutland is talking about building smart on day 3. I'm also representing Invicara. I'm a solutions consultant within Invicara. So we're going to start off this morning. We're going to have a presentation about computational design and structural engineering from Sean Carroll from Munster Technological University.
Thank you, Louise. Good morning, everyone. And I'm pleased to have the opportunity here to share my presentation this morning on integrating computational design into structural engineering workflows to enhance design automation. So I guess this presentation is based on the paper that my co-authors and I would have submitted to the conference this year. So my co-authors include Jason Lyne, who's an associate at Horgan Lynch Consulting Engineers, Michael Artriba, who's the BIM Level 9 coordinator here at MTU, and Ted McKenna, who's our BIM lead here at MTU. So maybe just to give you a quick overview of the presentation. So I'd like to start maybe with our research motivation and objective. I'll touch on Dynamo and automation. So for anyone who's new to this technology or who's looking to get into it, I'll give a very quick overview of how it's used. I'll then maybe look at how we went about automating a structural engineering workflow with Dynamo, and then maybe some of the results and conclusions that we drew from our research. So I guess to start maybe with the research motivation. So I guess I would have had a personal kind of research motivation with regards to this one, as I would have worked as a structural design engineer for 10+ years in the industry, both at home and abroad. And I guess over that time, I would have been exposed to a wide variety of different structural engineering workflows, from manual processes to kind of more increasingly digitized ones. And I would have always had an interest maybe in leveraging digital technologies to enhance design automation. So I guess what's the problem, or what's the premise of the research that we were looking at? So if we think of kind of a traditional structural engineering workflow, we have the two principal actors, the structural engineer and the structural technician. And there's this kind of duplication of geometry or modeling effort occurring, because while they're closely collaborating, we have the structural engineer creating a structural analytical model or a structural analysis model, and we have the CAD technician then trying to document that design. So I guess the design would have traditionally been documented in AutoCAD, but as BIM tools have become more prevalent, we're seeing Revit models, I guess, more prevalent of late. As BIM tools have become more prevalent, the structural analysis type models, they now do have integrations where we can export that structural analytical model to a BIM model, but still the situation persists that even though these models are being potentially exported at the start, as project changes occur, it goes back to this kind of separate process. So unfortunately, there's just frequently no direct link between the analytical model and BIM model, and this can lead to errors in the contract documentation. So I guess the research objective was to see how could Dynamo help here? How could we create a link from kind of the analytical model and the BIM model, and how could we try to automate a structural engineering workflow? So we wanted to try to present a parametrically controlled analytical model and BIM model for a prototype building structure, develop a quantification phase to that workflow. So I guess to come full circle in that structural engineering workflow, not just have the analytical and BIM model, but to actually quantify the bill of materials for that structure, and then maybe present the qualitative and quantitative benefits that such an approach might bring. So maybe just a very quick bit on Dynamo and automation. So for those new to the technology, Dynamo, it's an open source platform. It's a visual programming computational design tool, and it's been embedded within Revit since 2017. So for any of you that use Autodesk Revit, you've got this tool readily available to you. So I guess it's used by programmers and non-programmers alike. So any manual task that you can do in Revit, you can automate through the use of Dynamo. And we do so through the use of what are known as nodes and wires. Now, rather than talk too much about it, I guess the best way to kind of get hands-on with Dynamo would be to actually just take a quick look at the interface. So here's just a quick script. That's how we would automate maybe the geometry for a circle, where we take these nodes, we connect them, and we run the script. But if we just look at the interface itself, so with Dynamo, on the left-hand side here, we have a number of nodes, as they're known, or a number of categories for nodes, and this would be the inbuilt library. But as this technology has matured, we now have the ability to download what are known as packages. So we have a package manager up here, and there's increasingly more useful packages coming on stream. So I have an example here of the structural design package, which formed part of our research. So in the structural design package, I can select a node known as the truss.warn node. And this is how we can kind of automate a parametrically controlled truss. So when I have these number sliders, I can simply connect these into the truss.warn node. And now I have this parametric geometry that I can easily flex. And I guess it should almost start to become immediately apparent just the kind of power of such a tool, where you can, in the early concept stage of a project, you have this ability to rapidly prototype geometry. And once you have this geometry, I guess there's great interoperability with Dynamo. This could now go to a structural analysis software such as Autodesk Robot, or it could go to Autodesk Revit to be documented. So, Dynamo can become that hub in your structural engineering workflow. So manual tasks can be automated and enables interoperability between different platforms. And I guess it's all about this working smarter and not harder. So I guess that was kind of the background to Dynamo. So in terms of then trying to illustrate automating a structural engineering workflow, I guess the first thing we had to choose is which building or structural type would we choose. Now, there's many different structures that would be quite suited to automation, such as civil type structures, such as wind turbine foundation. I guess what's quite popular these days would be open-sided modular frames for modular construction. But I guess one of the most common structures that you're probably going to find throughout the country today would be a kind of a single-story steel-framed building. So I guess this is what we chose as our prototype structure. So for that structure, what we wanted to do is we wanted to use Dynamo as this hub. So Dynamo would be the hub where we can create what would be known as a master model. So we can create that geometry. And then that geometry, through the use of scripting, can be shared into your robot structural analysis software for the analysis and design. That same geometry within the Dynamo hub can be shared out to Autodesk Revit. So we have this direct link, keeping that geometry and that sequence of data flowing. And then once that Revit model is created, we can also kind of use it for quantification. So based on our literature review, we would have found quite a number of papers where what is known as this master model approach. So I guess as well, not to kind of reinvent the wheel, and I guess we had a kind of a design science approach to this research. So design science at its core, it's all about to develop knowledge that can be used by professionals in the field to design solutions to their field problems. So rather than creating a script from scratch, I guess we want to kind of bring an awareness to some of the tools that are out there. So Thomas Hudala has created a package known as the structural design package, which I've shown a brief tip of there a short time ago. And within this package, you do have the ability to automate a portal frame structure like you can see in the image here. So we wanted to kind of take Thomas Hudala's package as kind of the base for the start of this workflow, and then to move past that and to show how we can expand the workflow to not just have the analytical model and the analytical model phase, but we can also create a BIM model phase, and we can also quantify from that BIM model also. So I guess the premise would be, so again, I have Dynamo here. I would be using the structural design package to create a portal frame geometry like this. So then once that geometry is created, it can then go off the robot structural analysis, where as a structural engineer, I can now go into robot. Now all of the loads, the supports, the section sizes would have all been defined in Dynamo. It would have then gone to Autodesk Robot Structural Analysis Professional, where I can run the analysis. I can check my bending moments, my shear forces. I can physically design this structure. And then once I have that structure designed, again, I'm just kind of back to my master model in Dynamo, where I can then export that model with the kind of finalized sizes from my design to create that BIM model, which can then be documented. And I guess finally, to kind of complete the full structural engineering workflow, we can actually quantify the bill of materials from that BIM model also. So the full script, there would have been 2 scripts as part of this research. The first script was involving creating the Dynamo geometry. So we can see, so I have a short recording here now on the next slide, maybe to kind of illustrate this a bit further. But at the start of the script, this is where the Dynamo geometry is actually created. And similar to the short video of the truss that I showed you, we have these number sliders at the start where we can adjust the frame spacing. And again, you'll see that shortly. So we have all of these different nodes, again, coming from the structural design package, which create that portal frame geometry. Once that portal frame geometry is created, then we have a structural analysis package, as it's known, again, which can be downloaded within Dynamo. And this is where we can define analytical properties such as the material grade for robot, certain end releases or supports that would be within robot, and even loads or load combinations. So you're defining everything within robot or within Dynamo. You're not having to define it in another platform. And then finally, the last bit of our script is how we would export our BIM model into Revit. So just to kind of give a sense of what this would have looked like. So just to show you the geometry creation side of things. So this is the start of the script where, again, I have my number sliders. So I can take this geometry and in a very quick and a parametric way, I can quickly, I can explore this frame in the concept stage in a very quick way that would have been otherwise possible if I was trying to do this through kind of conventional approaches by manually trying to model such geometry in Revit. So I guess hopefully the benefits of trying to adopt such approach like this are starting to become apparent. So with any process that you're trying to define, then I guess you have to just simply define the process itself. So with this structural engineering workflow that we developed, the process was geometry inputs where you define your frame. So once you have your geometry inputs, then you actually create your frame. Once you have your frame created, you can start defining the analytical model. And once the analytical model is in place and you've done your design, you can then export it to Revit for your BIM model. And once your BIM model has been produced, you can then finally quantify from that right into Excel. So the final part of the script then, or the second part of the workflow, and my co-author, Jason Lyne, I'd like to acknowledge his work with regards to this element of it. So this is where we could create another script. And this is where we can take that BIM model now and we can extract data from the BIM model to basically quantify it. So what we have here is we have a workflow whereby we're identifying system families and particular families that we want, such as the structural framing, structural columns. We're reading that data out of the BIM model. We're taking particular parameters such as the nominal weight and the lengths of the various elements. We're processing that data and then we're writing it to Excel. So then you can write your bill of materials to Excel. So I guess when you think of kind of a traditional design and build contract that a structural engineer might enter into with a contractor, as soon as they have their design in place, one of the first things the contractor is going to want to know is what's the kind of quantity of steel. But not only that, they're probably going to want to break down of the various sizes, the lengths, and the weights. So this is a quick way of how we can automate that. So I guess that was the workflow that we developed. That's the script. That's that Dynamo work. So just in terms of the results, so we would have clearly created that direct link between geometry, analytical modeling, and kind of quantification. But in terms of kind of getting quantitative type results, so I would have went away and I would have actually physically modeled same type of structure within Autodesk Robot. So when you're creating such a structure manually, some of the tasks would be to create the actual analytical geometry, add supports, add releases, define section geometry. So I recorded the time that it would have taken me to actually carry out all of those steps. And I guess when we compare that to the amount of time that it took to simply just run the script, so the script will run in less than a minute or so, depending on the processing power of your machine. So you can immediately see kind of the benefits of introducing such an approach. And I guess the biggest benefit really is once you have that script in place, it's there to be reused forevermore. So that's on the analytical side. On the actual BIM modeling side, similar, I would have actually modeled the same structure in Revit. So again, creating columns, creating the rafters, creating the secondary support members, the bracing, timing myself to create all of those elements. And once again, of course, you can kind of see the clear benefits as to, again, script will run in a minute or less, whereas the actual modeling is going to take you an hour approximately or so. I guess if we had more time, it would have been great to actually get more structural engineers on board and try to get people to physically carry out this task and to see how it would have compared. But I guess given the time restraints, we simply carry this task out ourselves. And maybe just as an overall summary on the reports here, or on a summary of the results, on the analytical side, on the BIM modeling, it's kind of quite obvious just how much time saving there is. trying to compare the kind of manual task of creating a bill of materials compared to visual programming. The process isn't quite the same, but when we had our visual programming script up and running, again, it kind of runs in kind of 30 seconds or less, whereas a manual process of trying to create a schedule within Revit and then having to actually, create calculations because some of the parameters that you want to schedule possibly wouldn't be available to you, it takes that a little bit more time. So I guess just maybe to bring this to a close, just maybe some of the kind of key conclusions. So I guess the conclusions may probably be best presented in a graph that Joe Kindergren, who is a past president of DICE-D, presented in a paper in 2019. And it basically kind of identifies the tasks that we kind of focus on as structural engineers currently, where we have a heavy emphasis on the design and analysis side of things. So we're in this manual mode where we're heavy using our tools. But as tools such as Dynamo and computational design become more prevalent, it's going to release us from that heavy burden. So these tools, I guess, they're here to be leveraged, and it's not a question of if they're going to be leveraged, but when they're going to be leveraged. And I guess we were hoping that this research could go some way in maybe bringing more awareness to them and hopefully see more adoption to them. So just some of the key conclusions. So, Dynamo as a tool for structural engineering workflows, it has the potential to improve structural engineering workflow efficiency and reduce project hours. It has the ability to ensure data completeness, enables interoperability between different platforms, and has the ability to quickly test different concept designs. So I guess it's all about working smarter and not working harder. Thank you for your attention.
Thanks for that, Sean. Our next speaker is Barry Kirrane, who is a senior architectural technologist with Taylor McCartney Architects, and he's also from IT Sligo, and he is going to be presenting about innovation and transformation of project management practices in Ireland.
Oh, sorry. Hello, how's it going, everyone? Apologies. My name is Barry Kirrane. I'm from Taylor McCartney Architects, and I've just recently completed a master's degree in project management out at IT Sligo. And today I'm grateful for the opportunity to speak regarding my research paper titled Innovation Transformation of Multi-Project Management Practices in the AEC Sector. So basically, presentation overview. We'll talk a bit about the background to the research, briefly about my literature review, research methodology, my key findings, conclusion and recommendations. So just a bit of a background to the chosen research, I suppose. Look, I've spent about 14 years working within the construction industry, and I have a huge interest in how data is used within organizations in the AEC sector. So the objective was of the research was to gain a level of understanding regards multi-project management organizations and to establish if software tools were being implemented, and in addition to examine the culture and how data and knowledge management is influencing better decision making within these organizations. So we looked at, I suppose, companies in the AEC sector. We can see in 2018, the CSO shows that micro enterprises account for 91% of businesses. 92% of these are engaged in some form of construction. So most organizations in the AEC sector are, small to medium enterprises. I suppose companies within this sector are carrying out projects on a day-to-day basis, and the industry is very project-driven in nature at the moment. And I suppose projects are becoming very complex, fragmented, and data and information heavy. The amount of information on projects now is huge. So I suppose digitalization trends and how that might help with this information and data, and I suppose digitalization is happening. It's challenging organizations now more than ever. And I suppose the move towards automation, Internet of Things, big data, AI and information sharing is rapidly changing the landscape of organizations, and I suppose it's putting a greater pressure on organizations to increase performance and efficiencies throughout their organization through digitalization. So as part of my literature review, I carried out a thematic literature review, and I focused on the five following areas. So that was around multi-project management, the role of the PMO, big data, knowledge management, and project management tools. And just a brief summary of each of the terms there, I suppose. Look at multi-project management is managing multiple projects in a project environment simultaneously. The PMO, which is a project management office responsible for providing project management support within organizations, and can be running projects, and also looks after standardizing procedures and processes within organizations. Big data then, I suppose, look at big data is probably a relatively new term and trend. It's, I suppose, described as high volume, high velocity, and a high variant of information, and that would enable enhanced insight into decision making if the data is analyzed. So I suppose data has always been collected, but I suppose it's been collected in so many different ways now, and the analysis of this data has advanced so much. So, you know, some of this data being processed can nearly almost in real time give decision makers that information they need in organizations. So again, knowledge management, look at previous studies from the literature that we looked at, you know, said the AEC sector was problematic in sharing of information and communication within multi-project environments, largely because of the industry's fragmented structures, complexities of projects, and project-driven nature. And again, project management tools, I suppose, look at we're going through an industrial revolution 4.0. We're experiencing, and it's fundamentally changing the way we live, we work, and relate to each other. So look at the studies have shown that the utilization of software are supporting project management, and project portfolio management has increased lately. So I suppose just a brief overview of my methodology for the research. We chose a mixed method for the research, both qualitative and quantitative, or qualitative supplemented by a quantitative questionnaire. So the qualitative data collection, I suppose, was carried out with face-to-face semi-structured interviews. It was carried out from 5 individuals from within the construction industry. So, and these were like 2 from architectural, there was 1 from an engineering firm and 2 from a construction firm. And both, I suppose, there was 1 from a larger organization and 1 from a smaller organization. So the reason for choosing the interviews was, I suppose, to gain an understanding of people's experiences and knowledge within the construction industry. And I suppose the people that were interviewed were all in a position to influence the transition and change to digitalization, and to get an understanding of what measures they were taking, or if any, to utilize data or digital tools to be more efficient and better at making decision making. And again, the interviews had developed the questionnaire, and again, the questionnaire was sent out to professionals in the AEC sector, and we had 55 respondents. So just key findings, I suppose, from my research. As multi-project management, I suppose the literature proposed, from the literature review, it proposed a model that consisted of 3 segments: structures, people, and values. And this model suggested that, you know, that it would increase innovation and exploit the information delivered by projects faster, which would provide greater value for decision makers. And I suppose this was consistent within my own research, where during the interviews, the structures and processes and the resourcing of people were key to the guys that were interviewed. However, I found like the value of information and single source of truth there was a greater focus from the construction industry, and the respondents from the architectural engineering practices had a lesser kind of understanding of the value of data, and therefore were more reluctant to implement procedures for data collection. So that was kind of the findings on multi-project environments. The PMO, again, the term PMO was not very familiar within the majority of the interviewees. I suppose PMO is probably, from the literature again, expressed that it would be found in larger organizations. And I suppose going back to our analysis of the AEC sector, a lot of the companies are small to medium enterprises, and I suppose this could relate back to the unfamiliarity of the PMO. Now, there was one organization, a large construction firm that the lads I had interviewed, and they were utilizing the PMO within their organization. Digitalization, the findings, I suppose, in digitalization indicated the level of adoption was varied between the AEC sector. Most organizations were adopting, came from the construction companies. The architectural engineering companies seem to be a lot slower adopting software tools or even collecting descriptive data. And I suppose with data itself, we can see that, I suppose, big data, like there was 40% of participants from the questionnaire had heard of the term, and again, 22% of these were from the construction industry. However, like there was one the construction firm, they were utilizing big data within their construction firm. And I suppose one thing to note was, I just have a line here from him. And I suppose it wasn't until they brought in a professional to look at what they were doing in terms of cleansing the data properly, and really bringing them back to first principle and getting them to understand their workflows and what they actually wanted to get out of the data. And that's one of the key takeaways, is going back to first principles and understanding what you need. Culture, organizational culture, look at culture, I suppose, to break it down, is values, expectations, and informs the actions of all teams within the organization and influences how processes and procedures are carried out. And I suppose through my findings, there was obstacles such as organizational culture, time consumed with using digital platforms, I suppose, were two factors that influenced the adoption. And I suppose there was concerns about, we'll say, people working in organizations spending too long working or completing digital tools to collect data and taking them away from, you know, their engineering tasks, architecture or construction tasks. So again, we can see there 46% of participants from the questionnaire strongly agreed that culture within organizations can be one of the contributing factors to the adoption of digital tools. So just to kind of conclude, I suppose digitalization will drive innovation and transformation within the AEC sector through digital means by collecting data, and the extension of this data being analyzed and I suppose used for almost real-time decision making. The value of data, look at the industry is probably slow in adapting and utilizing digital tools, or possibly unaware of how valuable data is within their organizations themselves. Certainly the pandemic has driven a lot of organizations into a more digital world quicker than I suppose they would anticipate it. So again, I suppose the key to all the data is not, I suppose, the collection, but the acknowledgement of knowing what to analyze, you know, within their organization, leveraging, you know, the data and knowledge, you know, trying to work out what tasks they're doing and, you know, that they're not completing and being repetitive on each project, and try and create a standard for that, you know. So again, the kind of key to all of this is people, leadership, people, processes, and the evidence from the research suggested the adoption is about two key drivers, and that was people and processes. And this will ultimately lead to the change within organizations. And this change needs to come from a top-down approach with key leadership as an attribute for the adoption of digitalization within these multi-project organizations and practices. Look at, again, this strategy, I suppose, just some recommendations, I suppose, strategy and leadership. I suppose with the majority of companies being SMEs, you're going to have, I suppose, the company owner or manager being involved in an array of tasks and adding in, you know, the implementation of digital tools will add a greater pressure to these people because, you know, they're small and medium enterprises. So look at building digitalization into, you know, an overall company strategy would be, and creating a roadmap, you know, would be a starting point for these organizations. Again, developing skills or interests in current staff that they have, or you know, growing on, and as a way of probably growing on the digitalization within the organizations. You know, a lot of people would have an interest in digital, or some people would have an interest in digitalization, and you know, that can be harnessed within an organization. So again, look at just in terms of, you know, future research, I suppose, comprehensive research, I think would be greatly worth to the industry. You know, we're looking at maybe the risks and opportunity that digital technologies would bring to SMEs, and particular, like a focus on business models and skills within the industry. You know, looking at the skills that the industry maybe need now, you know, looking at data analysis and the like, and what the industry will require going forward. Like there's so much data, as I said previously, within organizations, and it's trying to harness and cut out this repetitiveness within different projects, you know, within, you know, consultancies. I know from our own point of view within the architectural, you know, it's about trying to minimize repeating that same task on every project, and I suppose within each organization. So yeah, look at that's me. That's me, and I thank you for listening, and thank you very much.
Thanks, Barry, for your very interesting presentation. It actually leads really nicely into Adalberto's presentation. So next up we have Adalberto Guerra Cabrera. Apologies if I pronounced that incorrectly, from IES. And you're going to be talking about building simulation software and ontology languages. So I'll leave it to you.
Thanks very much. Thank you. And that was very well pronounced. Right, so today I'm going to just speak to you about a bit of our work that we've been doing in IIS. So I titled this paper From Building Simulation Software to Ontology. And I want to also thank to my colleagues, Graham and Ereje, which are my teammates, software developers and team leader from the team that I work with. So just a bit of a overview. So I work for IES, Integrated Environmental Solutions, based on Glasgow, and we develop over the years the ISV simulation software tool, which is traditionally a desktop tool that can be used for doing thermal simulations and design Apache HVAC system using a thermal simulation engine that we call Apache. I work specifically on the R&D team, and more specifically on research on building operations. And we're very lucky because what we do is that we get funding to try to make more efficient all the process of integrating the simulation aspect of the of the analysis into the operation workflow. So for this chat, the overview will be that I will speak for a moment about the building metadata lifecycle, and then talk about a bit of a digital twin platform and the workflow to create one, and then the Apache data model, which is something that will be introduced here, and a couple of case studies of the work that we are doing. So about the metadata lifecycle. So typically during design stage, construction and commissioning, geometry-centric designs tend to be used. So things like IFC that we all will know, or green building XML, which is typically used for energy simulation. So throughout the stage of design, construction and commissioning, these formats have been working very well. There are many professionals using them every day and tend to work very well. So here, what we are looking here is more on the operational side. So then that we are seeing a trend where the operations, maintenance, and audit side, so during the operational side phase of a building, there is the need of using more flexible approaches, so not as rigid structures that allows you to grow your model over time. So let's say you do the handover of the building today, but then this the operationals, the sensors and the equipment that you will use, they will be growing over time. So this kind of, it's an organic structure that can be appended and amended over time based on the changing needs of the building. So this type of ontologies, like for instance, brick schema, or haystack, project haystack, real estate core, are having momentum, and they are also used as the preferred ontologies for things like cloud-based digital twin platform like Azure Digital Twins, or edge-based platforms that use this type of ontologies. So I'm just going to speak a bit about what could be a typical digital twin platform, where we have in the bottom side, we have the assets. So it could be buildings, it could be energy meters, electric vehicles, any sensor, IoT sensor, and so on, that can be connected to, or connected, all of these to a integration layer. Also, you could have alongside the business apps like conference room booking systems, a communication system, things like Microsoft Teams. Anyway, any application that can help you to describe how the building is being used and that can provide useful information about it. And other things could be like weather forecast. So the three main points of an integration layer is that you will have a data bus, where all it is pretty much like the highway where all the data goes through, and then you have the ontology, which describes with a unified vocabulary the different assets and the relationship across them, and then you have a single endpoint, which is an API that then you have applications that can take advantage of the data, and so the integration layer exposes the data for that. One step further for the digital twin will be the simulation side, where you can have the virtual assets. So those are, for instance, a building simulation that then you can use both to complement the analysis that the application can do. For instance, if you're doing MMV, you can use the simulation model as a baseline, and then so you can use it to estimate the differences between the energy use, so you can calculate savings and things like that. But also you could use the virtual model to test, for instance, if you are using things like operational optimization and you are doing control optimization, then you will want to test first and fine-tune your algorithms in a virtual asset before it's been deployed into an actual asset. So this is a trend that we are seeing happening, and of course what we want to use to do is to use our virtual simulation model to enable this type of applications. So how does this look? So the workflow to create this will look like this. So we have a system, a HVAC. This is just a building schematic. So we have a chillers, boiler, cooling coils, heating coils, and so on. Then if the building simulation team, for creating a calibrated model, will collect information of the data, will model the HVAC network, identify sensors, compare the simulated and meter results, just to make sure that the building is calibrated, that the building model is calibrated, fine-tune if required, and then update constantly as new changes occur. So on the other side, big companies will have another team specialized for this, which is for creating the brick ontology model, for example, which what they will do is to discover the list of relevant points, collect the information of the building, model the HVAC network or their relationships, name the sensors, create the brick model in a turtle file, and then update as changes occur. So we were doing this with a team collaboration with Schneider Electric at the beginning of the year, and then this seemed like a deja vu, and we were doing this work twice. So we were working with 2 different teams, and we were noticing that there were a lot of overlapping on what we were doing, but one was just for the building simulation, and the other was just for model the metadata. So the question was, okay, can we combine these things? Can we reduce the work and and the number of hours to create these things? And this is the origin of this research. So there has been, in parallel, there has been a lot of work in IES, where we are working on what we call the Apache data model, that it's a very compact version of the whole VE model that contains geometry, usage profiles, things like microflow, which is for simulation of wind flow simulation across building, soundcast for daylighting, the HVAC network, the thermal templates, and all of that is being compacted into a single model, which is called the Apache data model. Not only that, we have the Apache variable path, which is basically a unique variable path, similar to what you will see in things like MQTT or like unique identifiers, to access any of the variables in the model, both read and write. So that means that then we have around 1,200 different variables that can be accessed at any moment during the simulation time. So the idea here is, or what we did is to create this digital twin platform where we have the real building. We were given a list of points, and what we did was to take then the calibrated model and then have a plugin that generates that brick model for you, because the brick model, what we'll do is to see, okay, that sensor in real life, if it is mapped with a virtual sensor, then I know the relationships between different sensors. And basically it does that work for you, taking advantage that the building simulation team has already done that work of saying, how many sensors do we have here? Where are they connected to? What zones are connected at? And so on. So basically it's just recycling the knowledge and making sure that the naming conventions as well between the assets and the virtual assets match. So the integration layer have a single naming convention, saving time. So the work done basically consists of having a knowledge of how the VE identifies the components. They are called components internally, and we know that heating coil will be HC and then a number of digits there, cooling coil will be CC, and so on. So what we did was a mapping between the brick equipment terms and the component ID, the VE terms. We did the same with the points. That took a while. So we have what we call the Apache variable names like air temperature, and then we have also we have to map that with a brick point name, so room temperature sensor. So this will be equivalent. And then also finally we have to then identify the relationships and name them. So for instance, for the VE, it starts from a plant that has a water loop. The water loop will have some variables. Then the water loop will have a component assigned to it, and then that will be part of the network and so on. So what you see in black, it's the VE or the HVAC in the VE relationships. And what we did was quite straightforward, which is put the name, or we just translate that as a brick terminology, like feeds, that belongs to brick, its point of. So these terms are part of the brick terms. So once we had that, then what we did is a couple of case studies. And for instance, here we just built a very simple two-zone model, which constant air volume system, and this is how the HVAC model will look like. So you will have that the airflow and the heating coils and so on. So this is what a typical building simulation engineer will do, and then we expose a list of points. So we say, okay, we want to get these points as brick, and then the plugin, what it does is to export for you the brick model, which gives you the relationship across the sensors and things like the supply fan. So which is quite useful in case you want to do things like fault detections and diagnostics, for instance. because then you could implement a query. This is an example of a SparkQL query, which is used for brick, and then you will have you could have a plot which can show you things like energy saving opportunities. This representing the fan, the airflow of the fan on when the people from the zones connected to it, it's 0. So pretty much it's a kind of a typical rule checking that can help you to save energy, for example, for fault detection. The second case study was the complex office building model. It's an office from Schneider Electric. This was a very big model, almost 1,200 rooms, almost 2,000 HVAC components, and 45 systems, and they had 300 points. So this is what we found out, that we have a data engineering team modeling these 300 points, and at the same time you have the building simulation team building the whole calibrated model for this building. So on the left-hand side, you will see the work from the calibration team, from the building simulation team after they calibrated their model. And then what we did was to say, hey, okay, let's make sure that we have the equivalent brick model, so this brick model can be deployed into the databases and so on. So it took less than 5 seconds once the algorithm was ready. And yeah, so we could see that from this HVAC airside network, this is to simplify it or to this type of brick representation containing the equivalent information. So conclusion, so we spoke a bit about the integration platforms and how they enable multiple applications. I also mentioned that the model can be used to enhance those applications, like for instance, as using a virtual testbed or a comparing both simulated and metadata. And here we are saying that the calibrated building energy model will contain already a lot of the knowledge required to create those meta models. And the plan or the proposal here is that we create with the calibrated model, the initial brick model that can be used as the core of the digital twin platform that will be deployed with with live data and so on. And also because we have this automated plugin, then the goal is that if there is a change in the building in the future, for example, there is a new energy meter installed, so we have a new point that we need to add into the brick model, then we don't have to ask the data engineer team, hey, now I want you to look at the brick TTL file, which looks a very intimidating model, and I want you to add that new component. But in this case, what we could do is to go with the simulation team, make those changes, and then update with the brick model. So at the same time, we keep both models calibrated and coordinated, and yeah, so that's me. I think that's my presentation, and we're happy to answer any questions.
That's great, Adalberto. Thank you very much. That was really interesting, especially from my perspective, working with digital twins as well. So now we're going to have a panel session with all of the speakers. If anyone has any questions, I believe there's a Q&A area up on the top right-hand side of your screen where you can ask any questions for the panel members. I'm going to start off with Sean, if that's all right. Sean, you mentioned about the time savings that come from using the Dynamo process and the linking and the creation of the geometrical model at the same time as the analytical model. How has, I know you were talking about wanting to trial it with industry, but have you spoken to industry members about it, or kind of put feelers out to see how that might go down?
Yeah, I guess it was a design science approach is what we adopted for this research. So we did actually engage, like, I guess I would have contacted some contacts of mine from the industry, and I would have shown the workflow and got some feedbacks on what we were kind of developing to get a sense of, you know, what they feel is worth including or worth kind of exploring, I guess. I guess from kind of engaging with industry, Dynamo, it's used kind of quite extensively now, kind of in the architectural side of things. On the structural engineering side of things, probably less so. but again, becoming more prominent. But I guess it's all about just, whatever the process is that you have in your office, whatever discipline that you're coming from, there is the ability now to kind of help automate a lot of the tasks we do, whether it's drawing creation, whether it's simply renaming files in a BIM model. So it's kind of there to be leveraged, I guess,
And Barry, from your perspective, sitting in industry and sitting in an architectural practice, do you find that it's beginning to get more that Dynamo and automation processes, like you said, build smart or work smarter, not harder? Sorry, Sean, that was you. But do you find that these automation processes are required to? You were talking about the time it takes to upload files or to do these digital processes. Do you think automation comes into that?
Oh, most definitely, yeah. And the Dynamo, again, we've seen that within our own industry. But I think again, it's slow to be adopted. It's just people, I suppose, not aware of what the potential it can do for them. Certainly, the repetitiveness of tasks that we do within our industry, it's nearly you're repeating tasks every time for every project, and we have to get away from that. We need to start utilizing the likes of Dynamo and the likes of metadata for, within each, kind of looking at within organizations themselves and how they can, like, they collect so much data on each project, whether it's published or whether it's their own in-house stuff. And I suppose, you spend, how long do you spend clicking into folders, maybe searching for something previously that was done, and it gets siloed within a department nearly, or within an individual. It's built up on experience. But again, I go back to that knowledge management and trying to transfer that knowledge within the organization. I think is key, to extract that knowledge into a platform where within their organization, maybe, that will cut out this repetitiveness of tasks. And certainly Dynamo, I think, is actually a massive tool there that, we've heard about it, but actually we haven't utilized it. And I think it's that fear you hear that it's, it's nearly like coding or something, and people go, oh God, no. I think within our industry anyways, they're going to go, oh God, no, we want to draw lines, or, we want to, so I think it's starting to come. There's a lot more discussion on it, and hopefully, hopefully it will grow, I think it'll be great for companies, like, to make them more smarter and more efficient. I think, definitely they have to be embracing these tools, or, it comes as part of their package, even too, I think, their license, I think, so.
Yeah, I think Louise, just to come in behind Barry there as well, like, I guess the example and the automation that I would have demonstrated is very much like a geometry type thing, but perhaps the greatest benefits with it is this kind of data management. So like, where you have a project where you could have 1,000 drawings, and if all of those drawings have to be revved up, or you have to change a title block, okay, like, the client requests that just simply a couple of letters need to go in front of every drawing. I mean, getting one of your CAD technicians or your architects to go through that manual process, which might take a couple of hours, there's just simply no need really these days with some simple scripts. That can all be automated in a very short period of time. And once that script is there, it's there forevermore. Okay, so you develop it initially and it's there. But as Barry has alluded to, with everything, there is a bit of a learning curve. I would say that, it's a far more intuitive process though than some people realize. And I'm hoping we can kind of bring more of an awareness to that. And I guess we're actually very open to hearing from industry individuals all the time. We're always looking to collaborate with people and see how we can help them. So if anyone's watching today and would like to reach out, please feel free to do so.
And I know you spoke earlier on about the pandemic being a driver for change in digitalization. Obviously the massive labour shortage at the moment is obviously going to drive that also, and maybe that might be the kickstart for these tools that can support us in doing our jobs, for being more taken on within companies to actually get things done. Adalberto, I was just wondering, with regards to the building simulation models, how connected is that to the, like Sean obviously showed the example of connecting the analysis for the structural. How connected is all that, and how easy is that flow from the models that are created during the design and construction process into your digital twin and to create that?
Yep. Yeah, that's a very good question, and that's part of the effort. So part of the effort is to make this process even simpler. So we're looking into this ontology and all these graph-based descriptions of different relationships across sensors and so on. And actually, it's not that easy. I mean, there is a barrier there, and even me, when I go with my team and saying, "Hey guys, now there is this brick thing, or there is this other new haystack and so on," they are like, "You again? Is again?" Like there's a lot going on of new systems there, and they are commonly used at the research level. So what we want to do is that this is like a recipe book where pretty much as long as you are keeping your virtual simulation model up to date, then it will be just a matter of clicking to export, and then you will have the list of points that should match with the ones that will come from to your database. And that way, you can keep everything tidy, and then you're really as long as the calibrated model is up to date, then there shouldn't be any complication of the technicality-wise, at least. And that's kind of the goal, to reduce these entry barriers and keep the project tidy. So hopefully it will be reduced, as opposed to someone tidying a new file and adding the right convention of naming and so on, which can be complicated. Mm-hmm.
Okay, great. Thank you. And thank you to all our panelists and for your very interesting presentations this morning. That is the end of this session on smarter cities, smart building and data. I think we're having a tea break or tea and coffee break now. So I think the session starts back at 25 to 10 with Emma Hayes is your next plenary chair. And then there's keynotes to follow. So again, thank you all for attending this morning.
Thanks, Louise.
Thanks very much.